All right, this is section 3.7, we're calling it, is polynomial inequalities. We have talked about how to solve polynomial equations. Now we're going to step that up to inequalities. So to solve a polynomial inequality, such as x squared minus 2x minus 3 is less than 0, we use the fact that a polynomial can only change signs at its zeros. Between two consecutive zeros, a polynomial must be entirely positive or entirely negative. This means that when the real zeros of a polynomial are put in order, they divide the real number line into intervals in which the polynomial has no sign changes. These zeros are the key numbers of the inequality, and the resulting open intervals are the test intervals. For the inequality. So let's see what that means. We start off with pretending it's an equal sign. We're going to pretend we're solving x squared minus 2x minus 3 equals 0. We're going to factor x minus 3, x plus 1. We're going to get two solutions then, x equals 3 and x equals negative 1. Those are my key numbers. Then we create a number line of my key numbers in order, negative 1 and 3. And now I have test intervals. My test interval is negative infinity to negative 1. Well, take any number in that interval and plug it into my original function. I just need to know if it's positive or negative. Let's say I choose negative 2. I get 4 plus 4 minus 3. I get a negative. Pick any number between negative 1 and 3. I choose 0. I get negative 3. Uh-oh, I did my math wrong here. I get a positive here. I get positive 4 plus 4 minus 3. That's a positive. And then a number on the other side of 3. Let's say I choose 4. Let's see, I do 16 minus 8 minus 3 is still positive. Now my answer in which of these sections is less than 0? Well, where it's negative. So my answer is negative 1 to 3. And it's an interval, so it'll go in either parentheses or brackets. To find our test intervals, here's what we're going to do. We're going to find all real zeros of the polynomial and arrange them in increasing order. That way I can put them on a number line. We're going to use the key numbers to determine the test intervals. We're going to choose one representative x value in each test interval and evaluate the polynomial at that value. When the value is negative, the polynomial has negative values for every x value in that interval, which means this is going to be a solution to a less than 0 problem. You'll have something less than 0. When the value is positive, the polynomial has positive values for every x value in the interval. That means it is going to be a solution to something is greater than 0. So notice 0 is very key here. So let's try another one. X squared minus x minus 6 is less than 0. Remember, we pretend for a moment that it's equal to 0. And we factor x minus 3 times x plus 2. We get two solutions, x equals 3 and x equals negative 2. Those are my key numbers that I put on my number line. And my test intervals are negative infinity to negative 2, negative 2 to 3, and 3 to infinity. Try something in negative infinity to negative 2 in my original function. I like negative 3. I get 9 plus 3 minus 6 is a positive number. Something between negative 2 and 3, I like 0, I get a negative 6. And something bigger than 3, I like 4. 16 minus 4 minus 6 is still positive. Well, my solutions, I need less than 0, so that's anywhere that I got a negative. So that is negative 2 to 3. Now you might be wondering, why am I using parentheses on these? Because it is strictly less than. If I had a less than or equal to, then I'd have to start using brackets. All right, let's try some more. I'm going to pretend it's equal to 0. I'm not going to bother rewriting this one equal to 0. I'm just going to factor. X minus 5 times x plus 4. I'll still keep it less than 0. I know my key numbers then are going to be 5 and negative 4. Set up my number line. Negative 4, 5. Something smaller than negative 4, I'm going to have a a negative. Something between negative 4 and 5, I'm going to have a negative. Did my math wrong here. I got a positive here. Sorry, I keep flip-flopping that. And then something bigger than 5, I'm going to have a positive. I'm looking for less than 0, so that means it is between negative 4 and 5. Strictly less than, so I use parentheses for my answer. This next one, well, the only way to factor with 4 terms that we know of is to factor by grouping. My GCF of the first 2 terms is x squared, leaving me 2x minus 3. My GCF of the last 2 terms, I believe, is minus 16, which leaves me 2x minus 3. Ooh, greater than 0 this time. So I have 2x minus 3 times x squared minus 16 is greater than 0. I'm going to keep factoring because x squared minus 16 is x plus 4 times x minus 4. So my key numbers are 3 halves, negative 4, and positive 4. I'll put those on my number line. All right, if I plug in something less than negative 4, I'm going to get a negative. Something between negative 4 and 3 halves, I'm going to get a positive. Between 3 halves and 4, I'm going to get a negative. And something bigger than 4, I'm going to get a positive. Now this time I was looking for greater than 0, so it's anywhere that I had a positive. So we're going to have negative 4 to 3 halves, or 4 to infinity. Remember, infinity and negative infinity are possibilities in these intervals. All right, this one throws a new trick at me. Because that 0 was so key, I have to add this 4 over to the other side before I can do anything else. So I have 3x cubed minus x squared minus 12x plus 4 is greater than 0. Now I can factor by grouping. So I'm going to take out an x squared, leaving me 3 minus x. Nope. Take out an x squared, leaving me 3x minus 1. There we go. And I'm going to take out a minus 4, leaving me 3x minus 1. And then to fully factor, I have 3x minus 1 times x squared minus 4. Well, x squared minus 4 can factor again. I get x plus 2, x minus 2, which means my key numbers are 1/3, negative 2, and positive 2. Putting those on my number line in order. If I plug in something less than negative 2, I get a negative. Between negative 2 and 1/3, I get positive. Between 1/3 and 2, I get negative. And bigger than 2, I get a positive. I'm looking for greater than 0, sorry. So that means my answer is where it's positive. So I have negative 2 to 1/3, or 2 to infinity. The next one has the same trick. I need to get one side to be 0 first. So I'm going to subtract the 6 over. I have 4x squared minus 6x minus 6 is greater than 0. I'm going to take out a GCF of 2, leaving me 2x squared minus 3x minus 3. And I just realized I have a typo. In your notes, this is actually a 5. because this problem's impossible. This is a 5. We're actually going to factor that as it was. I'm going to go 4x and x. Two and 3, minus 8 plus 3. So my key numbers are actually negative 3/4 and positive 2. Your notes should have that correct. I just don't have it right on this page. So if I plug in something smaller than negative 3/4, I get a positive. Something between negative 3/4 and 2, I get a negative. And something bigger than 2, I get a positive. I'm looking for greater than 0. So my solutions are negative infinity to negative 3/4, or 2 to infinity. All right, next problem. This one's already set equal to 0, but you'll notice it's not factorable. If I tried to use quadratic formula, I'd get no real solutions. Which means on this number line that I draw, I can use any number. I like 0. If I plug in 0, I get a positive. Well, positives are greater than 0, so my solution is actually everything. So there are no real solutions to x squared plus 2x plus 4 equals 0. That has no real solutions. But the solution to the inequality is all real numbers. So that's one special case for us. Here's another special one. Let's factor this. I get x plus 1 times x plus 1. Notice the less than or equal to 0. All right, that means that I can include my endpoints now. My only key number is x equals negative 1. So if I plug in something smaller than negative 1, let's say negative 2, I'm going to get a positive. Something bigger than negative 1, I get a positive. Well, less than 0, nowhere was negative. So the only option is where it equaled 0. This is a strange case where I get just x equals negative 1, because it wasn't less than 0 anywhere. All right. X squared plus 3x plus 5 is less than 0. Well, if I treat this as an equation, it doesn't factor, and quadratic formula would give me no real solutions. Which means I try my number line, I try any number I want. I like 0, and I get a positive. Well, positive is never less than 0. So this is a special case where there are no real solutions to the inequality. And finally, one last example here. X squared minus 4x plus 4 is greater than 0. We factor, and you'll notice that it factors into x minus 2 squared, which means my only key number is x equals 2. If I put 2 on my number line, plug in something smaller, I get a positive. Something bigger, I get a positive. Notice that it's just greater than, not greater than or equal to. So really this is saying everything works except 2 itself. So everything but 2 is negative infinity to 2, or 2 to infinity. Another weird special case.